Hi guys, welcome back to another video, and today we will be talking again about how to solve linear systems, but this time we'll be using a new method called elimination. So let's get into it. So when the coefficients of the same variable in both equations have the same or opposite value, you can eliminate that variable by either subtracting or adding the two equations. And you need to ensure that the like terms are lined up before you add or subtract. So again, this might not make too much sense yet, but we're going to run through it with an example to clarify how it works. Okay, here we have an example of a linear system that we're going to try to solve using elimination. So we have the first equation, x plus y equals 4, and the second equation, 2x minus y equals 5. One thing to note is that when we have opposite signs, meaning if we have one positive coefficient and one negative coefficient when they're the same number, then we want to add the two equations together to cancel them out. Otherwise, if they're both, let's say, positive coefficients or negative coefficients of the same number, then we want to subtract them. Let me do a quick example to demonstrate that. So if I said positive 1 minus positive 1, these two have the same signs because they start with a positive, and this is also a positive one that I'm subtracting. And that would equal 0, meaning that would cancel out. So subtraction would be the right operation there. Whereas if I have a positive one and a negative one, then I want to add them together so I can cancel them out. A positive one and a negative one, I want to add these two so that they end up canceling out. And 1 plus negative 1 is equal to 0. Okay, let's move on. So let's try to solve this example through elimination. So the first step is to line up the equations as if we're doing long addition, and we want to line up the same variables together. So we have the x's on the left, they're lined up, we have the operations in the middle, and then we have our other variable, our y, lined up, and then we have equals whatever. So we need to line that up in whatever way. And now you can already see that I have added them, but why is that? I chose to add these because the y's have opposite signs. You can see x plus y and 2x minus y. So that means there's a positive y and there's a negative y. If I do y minus negative y, that's going to give me 2y. So I can't do subtraction. I need to do addition. I need to take a positive y and I need to add a negative y to cancel them out. So now, if I decide to add these two, as I put here, then these two will cancel out. So I'm only left with this being added and this being added. And that simplifies to 3x, x plus 2x, equals 9, 4 plus 5. And now we just solve this like a regular equation. 3x divided by 3 and 9 divided by 3 simplifies to x equals 3. And basically, now you can take this x value, put it into either original equation, and then you can find the value of the y, and then you have the solution for your linear system. I'm not going to substitute the x back into one of the equations just because I've already shown how to substitute and evaluate in one of my past videos. So if you'd like to check that out, you can go to one of my past videos to see how to plug values into equations and solve for them. So this is the main purpose of elimination. Your goal is to try to eliminate one variable from the equation by either adding or subtracting the equations, so you're only left with one variable which you can simply just solve the equation for. Okay, now let's look at another example. Now here's our second example of a linear system that we will solve through elimination. So we have our first equation, negative 2x minus y equals 4, and our second equation, 3x plus 2y equals 3. So I've just written them in long addition format, one on top of the other. And now we would think that we should check whether we should add or subtract first. However, do you see something wrong with why we cannot add or subtract yet? Well, it's because we don't have any same coefficients on either of our variable terms. So we must consider only coefficients of the same variables. So the coefficient of, let's say, x need to be the same in order for us to do it, or the coefficients of y need to be the same for it to be done. We can't have crossing variable coefficients be the same, like negative 2 and 2. That won't work. So we need a way to make these two the same, -2 and 3, or these two the same, -1 and +2. Now, the way we do this is we multiply the whole equation as needed in order to make a pair of coefficients equal to each other. So then we can eliminate them. So here, which equation would it make sense to multiply, and what would we multiply by to make one of the coefficients equal to the corresponding variable coefficient in the other equation? I see -y and +2y. So don't you think we can just multiply the top by 2, and that will give us -2 over here, and then we can eliminate. So here what you can do is multiply the first equation by 2, the whole equation, and that'll give you a coefficient on the top of -2y, and then you can do your elimination with this pair of variables right here. So let me show you what I mean. Here what I've done is that I've multiplied this whole top equation by 2. So I multiply every term in the whole equation by 2. 2 times -2x plus 2 times -y equals 2 times 4. That leaves me with -4x minus 2y equals 8. So now I've rewritten my equations, but now with my new equation that's multiplied by 2 completely. When you multiply the whole equation, it doesn't really change anything. So -2x minus y equals 4 is the same thing as saying this equation, which is now multiplied by 2. So now we have -4x minus 2y equals 8, and 3x plus 2y equals 3. Now we have a pair of coefficients that have the same value. So if you ever don't have two coefficients of the same value, you can multiply one or both equations to get the same coefficients. Now here we can decide whether we need to add or subtract. Now we have -2y and +2y. Now since those are opposite sides, that means we have to add. So I'm just going to put an addition sign right here. And that means these would cancel out. That would leave us with 0. And now we just need to add these. So -4x plus 3x would just be -x. And then 8 plus 3 would be 11. So we're left with -x equals 11. Our next step would be to divide each one by -1, since the coefficient on the x is -1. And that leaves us with x equals -11. And again, you can take the x, put it back into either the first or second equation, and you can solve for y. And then you would be able to solve your full linear system. So let me just quickly once again go over the steps to elimination. So first, if you need it, you need to multiply one or both equations to make a pair of coefficients have either the same or opposite values. Like we had in our example, we had -y and we had +2y. We multiplied the -y by 2 so we could have opposite values, -2y and +2y. And that way we can then eliminate them using addition, and then we could solve the new simple equation. So the second step is to line up the equations in long addition format with the like terms lined up. The third step, decide whether to add or subtract the equations in order to eliminate one of the variables. So remember, opposite signs mean add, and the same signs mean subtract. Your fourth step is to finish adding or subtracting the two equations and solve the remaining single variable equation. So after you add or subtract the two equations, you should only have one variable left in your multi-step equation, which you can simply just solve for. And then after you find the value of that variable, you take that value and you put it into one of the original equations that the question gave you. Then after you substitute that in, you can find the value for the other variable, and that would lead to your solution. You take the two values and you express it as x, y in terms of a coordinate. Thank you everyone for watching. I hope you thoroughly understood how to solve linear systems with elimination method. If you have any questions or suggestions, comments, concerns, please leave them in the comment section. Please like and subscribe, and I'll see you next time.